something that is not very clear to me is how the proposed scheme can cope with a situation where we have multiple paths with different round trip times, so that the feedback on the change of the available bandwidth can propagate at different speeds. So basically, what happens if flow A can detect before flow B that we are achieving some form of congestion? I think your proposal seems to imply that everything has the same delay in detecting some kind of problem, or in deciding a switch from one path to another.
Yes, exactly. So in the model that we're using for analysis and as a basis for developing these mechanisms, we assume a uniform information propagation time. This would be an interesting task for future work to look at how the model changes if there are path dependent information propagation times. But in general, for these systems, for example, for these intervals in the mechanisms that we have seen before, this interval would just need to be, or the duration of these intervals would just need to be spaced such that basically to the maximal information propagation time of flows, and then they would work as well.
Okay. Are there other questions?
Can I speak yet?
Yes.
Yeah, I have a question. In a large network, the number of paths can become quite large. Can you give a rough idea of the bookkeeping cost of all the incentives when the paths become many?
Yes, exactly. So we also, in our paper, we also discussed how these mechanisms would really be enforced in an interdomain network, and this is basically the question there is where in the network, so in which autonomous systems, by which network operator are they actually enforced. And what we suggest is that always when basically it's fundamental that the paths among which an endhost can oscillate, they basically have some intersections where these paths come together again. And the network operator, this intersection would also be a network operator that could detect the oscillation as an oscillation between two ingress interfaces. So from the perspective of the mechanism enforcer, or it would generally the complexity of enforcing the mechanism would depend on the number of ingress interfaces among which or that are comprised in a single oscillation pattern. And we give some or we sketch pathways for possible implementation that is efficient and does not hamper the forwarding or routers. But it would be definitely be interesting to look more at the complexity of enforcing these mechanisms, and especially contrast it to the cost or the damage that oscillation actually does, to find out when the enforcement of these mechanisms would make sense at all.
Okay. Any other question? Okay. So I